measures of variation. Okay, so the first things, let's take a look. The first terminology, deviation. Deviation of an entry X in a population data set is the difference between the entry and the mean mu of the data set. Okay, and we divide the deviation of X sorry, I think it's deviation of X. Write down is X minus mu. Okay, so that's the definition. Deviation is the difference between entry and the mu. So the formula is here. Deviation of X equals X minus mu. Okay, so in order to understand the deviation, I'm going to give you guys an example. A very simple example. Let's take a look. So, example 1. Now I gave you a bunch of data. That is 41, 38, 39, 45, 47, 41, 44, 41, 37, 42. Okay, and the formula give us the idea. In order to calculate the deviation, we needed to know what? We needed to know the mean value, right? Mean value. And the mean value, mu, here is the mu. That is a population mean or sample mean. If I give you this simple, it's the population mean or sample mean? Good job, you know it. So for the sample mean is X bar, okay, X bar. Good job, you memorize it. You know, I like small class because I can remember the student's name. If the class is so big, I couldn't remember the class student's name. Yeah, usually in small class, you know, students will come because I know their name. If they don't come, I will notice them. Okay, so we have summation divided by the capital N. Capital N, that means the number of population. Okay, we just needed to follow this formula. So summation, blah, 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 we're gonna add all of them, okay? And how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. And Now you're going to use your calculator to calculate the summation, and that equals 41.5. Okay, that's it. Now, after we get the mean value, for the deviation, gonna be the entry subtract the mean value. So entry. So each entry is 41, 38, 39, right? We have a bunch of entries. So you'd better use the table, otherwise too many, sorry. So we're gonna use a table, okay? Use a table. We have x value. X value means the entry. Entry means the value here, okay? So how many entries? We have 10. So the first one is 41. The second one is 38, 39, 45, 47, 41, 44, 41, 37, 42. Okay, so we have 10 entries. Okay, 10 entries corresponding here, right? Now, the deviation is defined as x minus mu. So that means 41 subtract 41.5. That equals what? Negative 0.5. Okay, that's the first one. And the second one gonna be 38 subtract, and this guy gonna give you negative 3.5. Okay, and the third row, 39 subtract 41.925 equals negative 2.5. And again, we can do the same things for the 45. So I just copy it from my notes. You can do it by yourself. Negative 0.5, 2.5, negative 0.5, 0.5. Right. So we finish this. We finish this table, and we know the first column, that is entry, right? The second column is deviation. Okay, the second column is deviation, and that's what we want, and that's what we want. And the interesting things, you guys can do some calculation about the summation of this column. You can do some summation of the second column. You will find the summation of this column equals 0. Okay, that's the most important, one of the important properties. Okay, the summation of all these deviations equals 0. Okay, so next time if you do the summation from the deviation and you find it's non-zero, that means you make a mistake. Okay, you make a mistake. Now, I'm gonna give you guys an example. Let you guys try it. Did you guys already copy it? Okay, very good. I'll let you guys try it. I'll just give you guys a very simple example. Okay, now I gave you this data set. We have 5 numbers. 32486. And I want you guys calculate the deviation for me. So calculate the deviation for me. And just follow the steps I gave to you. The first step, calculate the mu. The second step, list the table. Okay. The first column is entry, and then the second column is x minus mu. This entry subtracts this mu. That's it. Okay. Try it. Get on. Very good. Very good. So let me try it on board. Now, the first thing, so I want to calculate the mu divided by n, right? So summation 3 plus 2 plus 4 plus 8 plus 6. Divided by 5. And that we're gonna give you 23 divided by 5, 4.6. Okay, 4.6. And then after finish the first step, you're gonna calculate the deviation, because we have a bunch of data, so we're gonna use a table, will be more convenient. So we here, and we have 3, 2, 4, 8, 6. And then we do the subtraction. This entry subtract the mu, 4.6 equals negative 1.6. 2 subtract 4.6 will be negative 2.6. 4 negative 0.8. 6. 8 subtract 4.6 gonna be 3.4. 6 subtract 4.6 gonna be 1.4, right? And again, if we do the summation of the second column, you're gonna get 0. Very beautiful number, 0. It means nothing, but shows something, right? Okay. Do you guys need a more example or not? Do you understand? Very good. Very good. If you don't understand, just stop me, okay? Since you are the only 2 students here, you should have some VIP treatment in my class. Okay, so now let's continue. Definition. The population variance, okay, of a population data set of n entries is what? Take a look. The population variance, and this guy equals sigma square equals summation of x minus u squared divided by n. Okay, so that's a definition. And another definition is population standard deviation. Standard deviation. And this one will equals sigma square root of sigma square. And just do the square root for the population variance. Okay, so that's the 2 basic formula. One is population variance, and that defined is sigma square equals summation of x minus mu square, okay, divided by n. Okay, and the population standard deviation is very simple. After you get the population variance, you just needed to do the square root. Okay, after you get this one, you just do the square root, and you're gonna get population standard deviation. And be careful for the summation of this guy. So here we needed to do the deviation x minus mu, and then do the square. After you do the square, you do the summation. So you need to be careful about the order of the operation. So we do the subtraction, x minus mu, then do the square. After you do the square, then do the summation. Okay, so that's the order. And now let's take a look at an example. Still, I'm gonna use the our previous example. This guy. I'm gonna use this data set to calculate the variance, the population variance. Okay, and the first step still the same. We're gonna calculate the mu, because in the population variance we have the mu, right? So the first step always calculate the population mean. So we use this guy, and we do the same things we did before. Divided by 10, we got 41.5. Okay, so let's take a look. After we get the mu, we need to do subtraction, x minus mu. Okay, that is deviation, x minus mu. And then we do the square, right? We do the square. After we do the square, we do the summation, right? So we need to use the table again. Okay, we just add one extra step. or we're gonna use another column for the table. I need another column for the table. So I could just list the table again. That is x minus mu, x minus mu square. Okay. So the first one, we know we just copy it from our previous table, 41, 38. That is negative 0.5, negative 3.5. I just copy it, okay? Because we already did it in the last example. So it's 38, 39, 45, 47, 41, 44. $41, $42. Okay, now what are we gonna do? We're gonna do the square, x minus mu square, because what? Because I mentioned we need a square. We don't want the x minus mu, we want the square, okay? So if we do the square, negative 0.5 square gonna be a positive 0.25, right? Negative gonna be a positive. And negative 3.5 gonna be a 12.25. You guys can use your calculator to calculate the square, okay, in the test. 6.25, 12.25, and 30.25, 0.25, 6.25, 0.25, 20. Okay, so we already calculate the x minus mu square. We calculated this guy in the formula. Now we're gonna do the summation. Okay, after we calculate the square, we can do the summation, and the summation we can do the here. Summation. That will give you what? You add all this column, you're gonna get 88.5. Okay, 88.5. And we also called this guy SSX equals 88.5, and the SSX we called sum of squares. Okay, so that's the definition. Sum of the squares is defined as summation of this guy. Okay, so for this case, it's 88.5. Okay, 88.5. I introduced this terminology because in your on your math lab, my lab statistics will give you some problem like sum of the squares. So if you meet the sum of the square, that means the summation. Sorry, is the summation of the second column. Okay, second column. Very good. So we got the summation of the x minus mu square. According to the formula, we almost get it. Okay, is a sigma squared divided by n, right? Sigma equals this guy divided by n. So we need a divided by n. Sigma squared. We got 88.5 divided by n is 10. So we're gonna get 8.85. And the standard population standard deviation gonna be a square root of this guy. That equals what? That equals around 3.0. Okay, 3.0. And this guy is variance, population variance. And this guy is population standard deviation. Okay, so that's the this example. So how many steps we have? Let's take a look. So I assume the mu is the first step. Okay, mu is the first step. After you calculate the mu, you're gonna calculate the deviation. That's the second step. And I assume this step is the third step, the square. Okay, third step, and then do the summation of this column. After you get this column, the left work gonna be plug in the formula. Okay, so we plug in the summation of the square divided by the number 10 equals 8.85, and the population standard deviation gonna be a square root of this number equals 3.0. So total we have 1, 2, 3, 4, 4 steps. 4 steps. Okay, so I want you guys follow these 4 steps. We'll follow these 4 steps and finish this example. I gave you guys a very simple example. Try it by yourself. Try to calculate the population variance and population standard deviation. Okay, try it. So follow these 4 steps. Okay, 4 steps. follow the 4 steps, step by step, right? Don't jump. I know there's a lot of computation, and so you need to be careful. Did you get the answer? What's your answer for the population variance? 5.2. Let me check. Oh, you're right. How about the standard deviation? 2.3. Great. Congratulations. You got it. Fantastic. I feel so happy because this part is really very. I mean, I wouldn't like to say it's pretty tough, but it's requires a lot of steps. A lot of you guys probably will forget the steps when you are in the test, especially when you are very nervous, so you're gonna forget it. So that's the reason I want you guys to practice more. Okay, now let's take a look at this problem. So let's do it together. The first step, use the formula, right? Calculate the mean. So just follow the formula. 1 plus 2 plus 4 plus 6 plus 7 divided by 5 equals 4. Okay, and then we're gonna list the table. List the table. Calculate the x minus mu. X is 1, 2, 4, 6, 7. So x minus mu is going to be 1 minus 4, negative 3. 2 minus 4, negative 2. 4 minus 4, 0. 6 minus 4, 2, and 3. Okay, we finished the second step. We put it here. And the third step, we're going to do the square. Okay, because we want a square, not x minus mu. So we do the square, negative 3 square, 9, negative 2 square, 4, 0, 4, and 9. Okay, so when you do the square, everything should be positive. Everything should be positive. If you get a negative number, you make a mistake. Okay. Now, after you calculate the x minus mu square, then we're gonna do the summation. All we can write down is like that. SSX. Okay. SS sub x equals the summation of this guy. That's gonna be 26. Okay. And be careful on your MATLAB statistics. We call this guy is sum of squares. Okay. So in your homework, if that problem measuring sum of square, what is sum of square? That means the summation of the last column. That's it. Okay. Now, after we get this one, then we can calculate the population variance. And the sigma square divided by n. 26 divided by 1, 2, 3, 4, 5. 5 equal to 5.2. Okay. And the population standard standard deviation, we have sigma, just do the square root, and we're gonna get the answer is about 2.28, okay, 2.28. And the decimal, the number of decimals, it depends on the requirement. The MyLab statistics should give you a specific requirement for the decimals. Okay, so if that they want you keep 2 digits, you just keep 28. If they want just 1 digit, just 2.3. That's it. Okay. I think I need to give you guys another example. Okay, I just want to let you guys practice because I definitely will put such a problem in the test. So I just want to you guys get very familiar with this type of problems. Example 3. I gave you a bunch of data, okay, and calculate the population variance and the population standard deviation.
I have a question.
Sure, go ahead.
For the population standard, how do you know where to round, like which place?
It depends on the requirements from the problem. If the MyLab statistics requires 2 digits, then you just put the 2.28. If it requires 1 digit, you just put 2.3. Okay.
All right, thank you.
Yeah. It's weird. We get the same answer. It's so weird. You know, the weirdest thing that I just pick a problem by myself, randomly pick it, and I get the same answer. That means I can buy some lottery. Okay. Okay, let me write down the answer on board. So the first step, calculate the mean value, summation of all the entry divided by n, right? So just calculate all the values divided by the number, right? The number of data. And this we're gonna give you 26 divided by 5, 522. Okay. And the second step, we're gonna list a table. We have three columns. X minus mu, x minus mu square. Now we have the entries. That is -1, -2, -2, 1, 4. Okay, we calculate the deviation now. That's the second step. Third step, we're going to do the square.
The variance says the 26.
Do you have a question? Should it be 20?
Yeah, that 26. That's the
Oh,
that's the simulation of all squared.
sorry, it's a 20. So it should be a 4. You're right. Good job. Okay, it's a 4. So 20 divided by 5 equals 4. So here is entry should be 3 subtract 4 equals -1, -2. Okay. And we do the square. 1, 4, 4, 1, 16. Okay, 16. And then we do the summation. SSX, sum of square of this guy equals 26, right? 26. And then we can plug in the formula, calculate the population variance. Population variance, summation of this guy divided by n, and divided by 5 is 522. Okay, we get the same answer. And the population standard deviation, we're gonna do the square root of this guy. And it's about the same things, 2.28. Right, that's it. The reason I want to emphasize the population here, because there is another definition for the sample. Okay, here is about population. And now I'm gonna address the sample. Okay, of course, there's another definition for the sample. Okay. Definition. The sample variance and sample standard deviation of a sample data set of n entries. And entries are listed below. And we have these two formulas corresponding to sample. So for the sample variance, that is s squared x minus x bar squared divided by n minus 1. And the sample standard deviation, that is s square root of s squared, or you can write that as that. Okay, so let's take a look at the difference between the two. Of course, when you say the sample, we use the mean value x bar, and the number of data set we use little n instead of bigger N. Okay, and we have the formula for the sample variance. Now let's take a look at the definition of population variance. For the population variance, we have the same things, very similar. For the numerator, very similar. We do the square, we do the square, we do the square, and then we do the summation. We do the summation. The only difference is here. Here divided by capital N, and here divided by little n minus 1. A lot of students are gonna forget minus 1. Okay, so they just calculate divided by n. Okay, because they feel confused about the sample variance and the population variance. For the population variance, we just needed to divide by the number of data sets. Okay, for the sample variance, we need to divide by the number of data sets, subtract 1. Okay, so that's the point. That's the big difference between these two. And for the sample standard deviation, after you get this guy, just do the square root. That's it. Okay. Now let's take a look at an example. And I gave you guys this example. Let you guys try it. Follow these 4 steps. Okay. And this time you're gonna try to find the sample variance and standard deviation of the recovery times. And I gave you guys a bunch of data: 4, 7, 6, 7, 9, 5, 8, 10, 9, 8, 7, 10. Okay. Now follow these 4 steps. big difference here is about n minus 1. The other steps should be very, very similar. Okay, so just follow the steps. The first step, calculate the mean. Sample mean means x bar, right? Calculate the x bar, and then list the table calculates the deviation x minus x bar. And the second column, you're going to calculate the square, right? Then do the summation divided by n minus 1. Okay, so very similar to the previous example. The only difference is about the notation and n minus 1. Okay, n minus 1. You get it? I'm gonna give you guys 2 more minutes. What's your answer? What is sample variance as a square? How about you? What do you get? Oh, yeah, got it. 3.5. Around 3.5. Good job. Good job. So let's take a look the steps. So now it's about x bar, right? The mean value, the summation divided by n. So 4 plus 7 plus 6, 7 plus 7, blah, 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 blah. Add all of them, divided by the total number is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And if you do the summation divided by 12, then you're gonna get 7.5. Right? And then second step, we're gonna list the table. X minus bar, x minus bar square. So that's the second step. That's the third step. Okay, and then 4, 7, 6, 7, 9, 5, 8, 10, 9, 8, 7, 10. And 7, 10. We finished, copied all the entries. Okay, so now subtraction, x minus x bar. 4 minus mean value is negative minus 7.5 is negative 3.5. Right? And 7 minus 7.5 is negative 0.5. 6 minus 7.5 gonna be negative 1.5. Okay, then I just copy it. 5 minus negative 2.5, 0.5, 10, 8, 2.5. Okay. And then do the square. We're gonna get 12.25, 0.25, 2.25, 0.25, 2.25. This guy gonna 6.25, 0.25, 6.25, 2.25, 0.25, 0.25, 6.25. Okay, we finish all of them. Now we can calculate the summation of the second column. Of course, you can call this guy is sum of square. And this guy gonna give you the value is 39. Okay, if you add all these value together, you're gonna get a 39. Okay, now you can plug in the formula. You're gonna get sample variance. That is x minus x bar squared divided by n minus 1. And plug in 39. And be careful here. We have 12 numbers, and the formula wants us subtract 1. Okay, and you're gonna get around 3.5. 39 divided by 11 is about 3.5. And the sample standard deviation will be s square root over s squared. This guy is gonna give you about 1.9. Okay, 1.9. that's it. That's it. Okay. So I'm gonna wrap it up here. Have a nice day. Thank you for coming.